Introduction to Deep Learning. What is deep learning? Deep learning is a subset of machine learning that is inspired by the structure and function of the brain, specifically the neural networks that make up the brain. It involves training artificial neural networks on a large dataset in order to allow the network to learn and make intelligent decisions on its own. One key difference between deep learning and traditional machine learning is the level of human intervention required. In traditional machine learning, the features of the data must be identified and selected by the person designing the model. In deep learning, the neural network is able to learn and identify these features on its own, which can lead to more accurate models for certain types of problems. Another difference is the complexity of the models used. Traditional machine learning algorithms tend to be less complex, while deep learning models can have many layers and a large number of parameters. This added complexity allows deep learning models to learn more intricate patterns in the data, but also requires more computing power and time to train. Overall, deep learning has been successful in solving many complex problems that were previously difficult to tackle with traditional machine learning techniques, such as image and speech recognition. Deep learning is particularly well suited for problems that involve unstructured or semi-structured data, such as images, audio, and text. It can learn to identify patterns and features in this type of data that are not easily discernible by humans. Deep learning models can be trained on very large datasets, which allows them to learn a wide variety of features and patterns in the data. This can lead to highly accurate models, but also requires a lot of computing power and time to train. Deep learning is often implemented using neural network architectures, such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs. These architectures are designed to process and learn from data in different ways, depending on the nature of the problem being solved. There are many tools and libraries available for implementing deep learning models, including TensorFlow, Keras, PyTorch, and others. These tools make it easier to design, train, and deploy deep learning models, but they do require some programming knowledge. The field of deep learning is constantly evolving, with new techniques and architectures being developed all the time. Some of the current trends in deep learning include the use of transformers, which are a type of neural network architecture that has been successful in natural language processing tasks, and the use of graph neural networks, which can be used to process data with complex relationships. One important aspect of deep learning is the ability to use it for unsupervised learning tasks. In unsupervised learning, the model is not given any labeled examples and must learn to identify patterns in the data on its own. Deep learning models can be used for unsupervised learning tasks such as clustering, dimensionality reduction, and anomaly detection. Another important aspect of deep learning is the ability to use it for reinforcement learning tasks. In reinforcement learning, the model is trained to make decisions in an environment in order to maximize a reward. Deep learning models can be used for reinforcement learning tasks such as game playing and robot control. Deep learning models can be computationally intensive to train and may require specialized hardware, such as graphics processing units, GPUs, in order to run efficiently. There are also many considerations to keep in mind when designing and training deep learning models, such as choosing the appropriate neural network architecture, selecting the right hyperparameters, and preventing overfitting. One important aspect of deep learning is the ability to use it for generating content. For example, deep learning models can be used to generate text, images, and audio. This is achieved through the use of generative models, which learn to replicate the distribution of the data and can generate new examples that are similar to the training data. Another important aspect of deep learning is the ability to use it for interpretability and explainability. While deep learning models can achieve very high accuracy, they are often considered to be black boxes, because it can be difficult to understand how they arrived at their predictions. There are various techniques that can be used to make deep learning models more interpretable and explainable, such as sensitivity analysis and feature visualization. Deep learning is a rapidly growing field with many active research areas. Some of the current challenges and open research questions in deep learning include improving the efficiency of deep learning models, developing better methods for handling small datasets, and addressing ethical and privacy concerns. Here is an overview of TensorFlow, Keras, PyTorch, and Python. TensorFlow is an open-source software library for machine learning and deep learning. TensorFlow was developed by Google and is widely used for a variety of tasks, including training and deploying deep learning models. TensorFlow provides a flexible and efficient platform for building and deploying machine learning models, with support for a wide range of hardware platforms and programming languages. Keras is an open-source software library for building and training deep learning models. Keras is built on top of TensorFlow and provides a high-level interface for defining and training deep learning models. Keras is popular because it is easy to use and allows users to quickly prototype and build deep learning models without worrying about the underlying details. PyTorch is an open-source software library for machine learning and deep learning. PyTorch was developed by Facebook and is widely used for a variety of tasks, including training and deploying deep learning models. PyTorch provides a flexible and efficient platform for building and deploying machine learning models, with support for a wide range of hardware platforms and programming languages. Python is a popular programming language that is widely used for machine learning and data science. Python has a large and active community of developers and users, and there are many libraries and frameworks available for machine learning and data science tasks. Python is known for its simplicity and readability, making it a good choice for beginners and experienced developers alike. Here are a few additional points to consider when learning about TensorFlow, Keras, PyTorch, and Python. One of the main advantages of TensorFlow is its ability to perform efficient numerical computations using dataflow graphs. TensorFlow allows users to define a computation as a graph of tensors, multi-dimensional arrays, and execute the graph on a variety of hardware platforms, including CPUs, GPUs, and TPUs. This makes TensorFlow well suited for large-scale machine learning tasks such as training deep learning models. Keras is a high-level interface for defining and training deep learning models, which makes it easy to use and allows users to quickly prototype and build deep learning models. Keras is built on top of TensorFlow and provides a range of pre-built models and layers that can be used to build deep learning models for a variety of tasks. PyTorch is an open-source software library for machine learning and deep learning that is particularly popular in the research community. PyTorch provides a flexible and efficient platform for building and deploying machine learning models, and has strong support for dynamic computation and automatic differentiation. PyTorch also has a large and active community of developers and users. Python is a popular programming language that is widely used for machine learning and data science tasks. Python has a large and active community of developers and users, and there are many libraries and frameworks available for machine learning and data science tasks. Python is known for its simplicity and readability, making it a good choice for beginners and experienced developers alike. One key aspect of deep learning is the ability of the neural network to learn and extract features from the data automatically. This is achieved through the use of hidden layers in the network, which are responsible for learning complex representations of the data. Deep learning models are trained using an optimization algorithm, which adjusts the weights and biases of the network in order to minimize the loss function. The loss function measures how well the model is performing and provides a way to compare different models. There are many different approaches to training deep learning models, including supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained on labeled data, where the desired output is known. In unsupervised learning, the model must learn to identify patterns in the data without any labeled examples. Reinforcement learning involves training a model to make decisions in an environment in order to maximize a reward. Deep learning models can be highly accurate, but they can also be prone to overfitting, which occurs when the model is too complex and learns patterns that are specific to the training data but do not generalize well to new data. Overfitting can be prevented through techniques such as regularization and early stopping. One important aspect of deep learning is the ability to use pre-trained models for transfer learning. Transfer learning involves using a model that has already been trained on a large dataset and adapting it for a new task with a different dataset. This can be an efficient way to build deep learning models, especially when there is a limited amount of labeled data available. Deep learning has been applied to a wide variety of fields, including natural language processing, computer vision, and speech recognition. In natural language processing, deep learning models can be used to perform tasks such as translation, summarization, and sentiment analysis. In computer vision, deep learning models can be used for tasks such as object detection and image classification. In speech recognition, deep learning models can be used to transcribe and translate spoken language. The field of deep learning is constantly evolving, with new techniques and architectures being developed all the time. Some of the current trends in deep learning include the use of transformers, which are a type of neural network.